Hello, welcome back everybody to Math 2413, more on math. Today we're going to talk about Chapter 3, Section 7, Implicit Differentiation. Up until now, our x's and y's have been separated. So when I look for a derivative, I just do the process. So this y prime is actually dy dx equals 8x. Fine. So x and y are separated. But now we're getting to a realm where x and y do not need to be separated. They're going to be in the same arena. So we're going to look at equations that could be like this, where x and y are scattered throughout there and we can't separate them. So that's what implicit differentiation is all about. So when we do this, we're going to use the same rules. We're going to use the chain rule, the product rule, the quotient rule. But the only difference, whenever you take a derivative of a y value, place a dy dx behind it. So let's say we had x squared plus y squared equals 3. Alright? So we'll take the derivative of this. We'd have 2x. This is treated the same way, 2y. But now, since I took a derivative of y, you have to put a dy dx behind it. And derivative of a constant is 0. Because our objective here is to get dy dx by itself. So we'd have to move everything around to isolate dy dx. So for example, so we had 2x plus 2y dy dx equals 0. Subtract 2x from both sides. Negative 2x. Divide both sides by 2y. So now we have dy dx by itself. The 2's cancel, so we have negative x over y. And there we have it. And if you're given a point, then just plug them in there. And that equals your slope. Slope at that point. Alright, so far we're going to use everything we've discussed in the past. Now we're going to look at a little bit different how we approach it. This is the first page. Okay. Section 7. Put these on separate piece of papers. These are going to be pretty drawn out. Okay, so this is 3, section 7, question 1. 2x squared y plus 5x y squared equals 6. See, now it's asking for dy dx. That's what we have to isolate. So, here we have a product. So we have x squared and y. That's f and g. F prime, g prime. So it's 2x. The derivative of y, since it's a constant, is 1. But we have to put a dy dx behind it. So it's 2 times 2xy, that's these two, plus x squared dy dx. That's the derivative of this first part. We do the same thing here. X, y squared, derivative of x is 1, derivative of y squared is 2y. Remember, dy dx. Anytime you take a derivative of y, you have to take a dy dx. So 1 times y squared is y squared, plus 2y, x is 2xy, dy dx equals derivative of 6 is 0. So now let's get rid of the parentheses. 2 times 2 is 4 xy plus 2 x squared dy dx, 5y squared plus 10xy dy dx equals 0. Now, anything that has dy dx has to be on one side. Anything that doesn't have dy dx moves to the other. So we get rid of this one by subtracting 4xy and subtracting 5y squared from both sides. So those cancel, those cancel. 2x squared dy dx plus 10xy dy dx is negative 4xy minus y squared. Now I'm trying to get, since both of these have a dy dx in common, I can factor it out. So I take out the dy dx out of both of those. I'm left with 2x squared plus 10xy equals 4xy minus 5y squared. Now, since I'm trying to get the dy dx by itself, I divide both sides by 2x squared plus 10xy. So that cancels. So dy dx is negative 4xy minus 5y squared over 2x squared plus 10xy. And there's your answer for number 1. Negative 4xy minus 5y squared, 2x squared plus 10xy. That's the first one. Now the second one. Three, 7, 2. Question number 2. We have x to the 5th plus y to the 5th equals 40xy. Derivative of the first one, so it's 5x to the 4th plus, that's two separate terms, so derivative of y to the 5th is 5y to the 4th dy dx. Anytime you take a derivative of y, put dy dx behind it. 40. Here's a product, x and y. Derivative of x is 1. Derivative of y is 1, but it's a dy dx. So it's 1 times y is y plus x dy dx. Get rid of the parentheses. 40y plus 40x dy dx. Right, let's get all the dy dx's to one side. So let's move these over here. And everything that's not a dy dx, that goes to the other side. No, so I have 5y to the 4th dy dx minus 40x dy dx equals 40y minus 5x to the 4th. Factor out the dy dx. I got 5y to the 4th, 40x. Divide both sides by 5y to the 4. So those cancel, leaving me with dy dx. Now they all have a 5 in common. 5 goes into 48 times. That 5 is gone. Y to the 4th minus 8x. So that's my answer. 8y minus x to the 4th, y to the 4th minus 8x. There. That's number 2. And that goes here. Eight y minus x to the 4th, y to the 4th minus 8x. Number 3. Chapter 3, Section 7, Question 3. 4y squared equals 3x minus 5. Take derivatives of the entire function. So it's constant leave alone. So bring down the 2. dy dx. Take a derivative of the y squared. This is f and g, so f is 3x minus 5. G is 3x plus 5. F prime is 3. G prime is 3. So it's 3 times 3x plus 5. Since it's division, I subtract 3x minus 5 all over 3x plus 5. Remember, the bottom number is always squared. Four times 2 is 8. dy dx. So 3 times 3 is 9x. 3 times 5 is 15. Negative 3 is negative 9x. Negative is a positive. 3 times 5 is 15. The 9x's cancel. (15 plus 15 is 30). Divide both sides by 8y. This is 1 over 8y. So those are gone, so I have dy dx. Two goes into 8 4 times. 2 goes into 30 15 times. So we have is 15 4y 3x plus 5 squared. There's the answer. All right, number 4. Question number 4. This one says use implicit differentiation x equals tangent y. So take derivative of both sides. Derivative of x is 1. Derivative of tangent is secant squared times the derivative of the inside, which is 1 dy dx. To get dy dx, I have to divide both sides by secant y, secant squared y. So dy dx is 1 over secant squared y. 1 over secant squared y is cosine squared y. Because remember, secant is 1 over cosine, but 1 over secant is cosine over 1. So there's my answer. Number 5. Cosine r theta to the 4th equals 1/4. Cosine r theta to the 4th equals 1/4. Derivative of both sides. Derivative of cosine is negative sine. Derivative of the inside is with theta. So we have r theta, so it's r 4r theta to the third. Derivative of constant is 0. dr. We have to find what's this say? It says dr d theta. So I'm taking with respect to r. So this one's going to be derivative of r is just 1, so it's theta to the fourth dr d theta equals 0. With respect to what's on the bottom, I had it right earlier. It's a product. Oops. So derivative of this is r and theta over 4. So derivative of r is 1. dr d theta, and derivative of theta to 4 is 4 theta cubed. So it's negative sine r theta to the fourth times theta to the fourth dr d theta plus 4r theta cubed equals 0. But it's a constant. d theta minus sine r theta to the fourth 4r theta to the cubed equals 0. So I have negative sine r theta to the fourth dr d theta. Move this to the other side, so it's sine r theta to the fourth 4r theta to the cubed. That's 0. I'm trying to get dr, so I divide both sides by sine r theta to the fourth. So that's gone, that's gone. Change the sign, so that becomes positive, that becomes a negative. So this, I'm sorry, this is r to the fourth, theta to the fourth. Yeah, right there. Theta to the fourth, theta to the fourth, theta to the fourth, theta to the fourth. Divide by theta to the fourth. dr d theta equals, 3 of them canceled, negative 4r over theta. I like dealing with x's and y's better than I do r's and thetas. So that was number 5. So it's negative 4r over theta. Alright, number 6. Three, 7, number 6. Okay, it says if x cubed plus y cubed equals 19, then find the second derivative at negative 2 thirds. Okay. Let's find the first derivative. So it's 3x squared, 3y squared, dy dx equals 0. Move the non-equations out of there, so it's 3y squared dy dx is negative 3x squared. Divide both sides by 3y squared. So it's dy dx is equal to negative x squared over y squared. That's the first derivative. Okay, now let's find the second derivative. Okay, we have to remember this. We have to come back to this. So the second derivative. This is a rational equation. So f is that, g is that. Derivative of that is negative 2x, 2y dy dx. Yes. So it's d squared y dx squared. So it's negative 2x times y, that's that, minus the negative x squared 2y dy dx all over y squared squared. So that becomes a plus. All right. So now we can plug in at both of these places. Remember, we're supposed to, at that point, we need to know what dy dx, because that's what we have right there. So we have negative of negative 2 squared over 3 squared. So it's negative 4 over 9. That's dy dx. So we have negative 2 times negative 2 times 3 squared plus negative 2 squared 2 times 3 times negative 4 over 9, 3 to the 4th power. 2 times 2 is 4. Okay. This here, that's 9. Positive, negative is positive. 9 times 4 is 36. 4 8 times 3, 24. Makes it a minus. Take that 4 over 9. So we have to multiply 36 times 9, because we want a common denominator of 9. For 54, 27, 32. Minus 24 to 4 is 16, 96. $324 minus 96. 8. 228 divided by, well, 9 times 81, 729. Now let's simplify this stuff. See, are 3 divisible? 18 and 12, so 3 goes in there. 3 goes in 22 7 times, with 1 left over. 3 goes in 18 6 times. 3 goes into 7 twice, with 1 left over. 3 goes into 12 4 times. And there's our answers. Because it's not simplifiable any further. 76, 243. Okay, how did I get from here to here? This is, I took the top fraction, 324 minus 96. That was 228 over 9. The top fraction, 228, leave it alone, over 9. Flip the bottom and multiply. 228 times 1 is 228. 81 times 9 is 729. That's how I got that. And then I divide both of these numbers by 3, because they both are divisible by 3. Next sheet. Number 7. Find the slope at the given point. 377. 9y9 plus 7x9 equals 2y plus 14x at 1, 1. Find m. Remember, m is the same thing as dy dx. So, the first derivative, take this out here, makes it 81 y to the 8 dy dx. Anytime you take derivative of y, you have to put dy dx. 9 times 7 is 63. 8. Derivative of y is 1, so dy dx. Derivative of x is 1 is 14. here we want to, since we're looking for dy dx, we just put 1 and 1 in place of 63 times 1. So 1 to the power 8, it's 1, so nothing happens there. 1 to 8. So I subtract 2 dy dx from both sides. And I subtract 63 from both sides. So 81 minus 2 is 79. 63 is bigger, so it's negative. 63 minus 14 is negative 49. Divide both sides by 79. So the slope is negative 49 over 79. That's that. Ta-da! Yeah, all I did was, since I had all these things, the derivatives taken, I just went ahead and plugged in 1 and 1 in place of my numbers and solved for dy dx. Three, 7, 8. This one says, find the slopes. It says, find the slope of the curve at the given point. No. Find the slope of the devil's curve. Y to the 4th. Let's look at two simple ones. Y to the 4th minus 4y squared equals x to the 4th minus 9x squared. So let's first find the slopes, and then we'll look at the specific points. So derivative of this one is 4y to the 3rd dy dx. Bring the 2 down. 4 times 2 is 8. Y dy dx. 4x cubed. Bring the 2 down. 9 times 2 is 18. X. Since they're both there, I have to factor them out. And the other side is that. Divide both sides by 4y cubed minus 8y. So my slope, my equation for a slope is this. Now it wants us to look at the slopes at all 4 of these points. At negative 3, 2, negative 3, negative 2, positive 3, 2, positive 3, negative 2. So at negative 3, negative 2, at 3, 2, no, that's negative 3, so negative 3, positive 2 is just negative 3, negative 2, 3, negative 2. These are the 4 points I plug in for x and y. So the first one, I call that 1, 2, 3, 4. So dy dx 1. So for x and y, so I have 4 negative 3 cubed minus 18 negative 3, 4 squared cubed minus 8 times 2. Negative 3 cubed is negative 27. Negative negative is a positive. 18 times 3 is 54. 2 cubed is 8. 8 times 4, 32. No, 8 times 4. Yeah, it's 32. Minus 8 times 2 is 16. 4 times 27 is 108. Negative 108 plus 54. 32 minus 16 is 16. Top number is negative 108 minus 54 is 54 over 16. They're both even, divisible by 2. So half of 54 is 27. Half of 6 is 8. Okay, that's the first one. So at negative 3, 2, it's negative 27 over 8. That's the slope. Dy dx 2. Negative 3, negative 2. So I have negative 3 cubed, negative 18 minus 3, negative 2 squared cubed minus 8 minus 2. The top number is going to be the same, so it's going to stay at negative 54. What do we have on the bottom? Negative 2 cubed is negative 8 times 4, negative 32. Negative 8, negative 2 is positive 16. So negative 54 over negative 16 is 27 over 8. Dy dx 3. This one's at 3, 2. 4 times 3 cubed minus 18 times 3. 4 times 2 cubed minus 8 times 2. Well, this one's the same as that one up top. So it's going to be 16. 3 cubed is 27. So it's going to be the same numbers, except there's going to be a positive 54. 27 over 8. Dy dx in the fourth location, which is at 3, negative 2. 4, 3 cubed minus 18 times 3, and negative 2. 4 times negative 2 cubed minus 8 times negative 2. But negative 2, it's negative 16. At positive 3, it's positive 54. So it's going to be negative 27 over 8. And we can see that. Because at negative 3, 2, slope is negative. At -3, -2, the slope is positive. So -3, -2 is 2. Also, in the first quadrant, at 3, 2, it's a positive slope. That's at 3. And at 4, it's negative. Sure enough, those are the answers. So -27/8, 27/8, 27/8, and -27/8. Alright, so that does it for that section. We're almost done with the chapter. Good luck, everybody.